In this video, we're going to be looking at how to create a small sample confidence interval for mu1 minus mu2. And we're going to consider it a small sample if our n1 value is less than 30 or our n2 value is less than 30. And now we also have to make a simple assumption. So that assumption is going to be that our sigma 1 squared value is equal to our sigma 2 squared value. And then we have the same assumptions that we normally have, where the two samples are randomly selected in an independent way from the two target populations, and that both sample populations have distributions that are approximately normal. Now to figure out what our confidence interval looks like, we're going to say x1 bar minus our x2 bar value plus or minus our t sub alpha over 2. Now at this point, this is kind of what we would assume our confidence interval would look like. We're again subbing in this for our x bar value and our t sub alpha over 2 since it's a small sample. Now this is where our formula kind of changes. So we're going to now create our standard deviation for this. And our standard deviation is going to be a new formula that we haven't seen before. And it's going to be sp squared times 1 over n1 plus 1 over n2. And that whole value we're going to take the square root of. Now we have our formula for what our confidence interval looks like, but we still don't really know what our sp squared value is. So we have a formula for that. We have sp squared is equal to our n1 minus 1 times s1 squared. Add that to our n2 minus 1 times s2 squared. And then we're going to divide that whole value by n1 plus n2 minus 2. Now we have one piece of information that we're still missing here. So we have our t sub alpha over 2, but we have yet to say how we're actually going to get the degrees of freedom for that. And our degrees of freedom for our t sub alpha over 2, so t sub alpha over 2 degrees of freedom is equal to, we have our n1 plus our n2, and then we're again going to subtract off our 2. So the same that we're going to see on the bottom here is what our degrees of freedom is for our t sub alpha over 2. So to get our confidence interval, we just plug in all that information once we have it, and we're going to get our x1 bar minus our x2 bar plus or minus our t of alpha over 2 with n1 plus n2 minus 2 degrees of freedom multiplied by the square root of sp squared times 1 over n1 plus 1 over n2.